So section 9.4 is about what are called parametric equations. And a parametric equation, it allows us to introduce another variable into our realm, our world. So normally we would just have an equation involving x and y, x equals this or y equals that or something along those lines. We just had two variables and we had an input and an output. We could substitute something in for x and get a y value, or substitute something in for y and get an x value. Now we're going to introduce a third variable. And we've all seen these problems before where you're given an equation. Let's see, look at this one here. Y equals negative x squared over 72 plus x. And we're told that this is the path the object flies or goes. And it's this equation right here, this graph here. And we know that the horizontal distance is your x value, and the y value is your vertical distance. So this point right here, 36, 18, what that tells us is that when the horizontal height or horizontal distance is 36 meters, or sorry, feet, 36 feet, the object is 18 feet off the ground. Now, we've had some situations before where we are told that, x is time and y is the height, and that's different than what we're being told right now. We're being told that this is the path that the object follows. It starts here, it gets shot up, it reaches that vertex when it's 36 feet away, and it reaches a height of 18 feet. And then it comes back down right here. So it traveled a total distance of 72 feet horizontally and reached a maximum height of 18 feet vertically. But we don't know when this happened. So did it take 5 seconds to reach the vertex right here? Was the object only in the air for 10 seconds? 7 seconds? We don't know. And that's why we use this third variable called the parameter to let us know, okay, at time equals 2 seconds, what is the vertical distance and what is the horizontal distance? And that's why we have two parametric equations. All right, so after 5 seconds, I can figure out the horizontal distance, and after 5 seconds, I can figure out the vertical distance using that other parametric equation. So it's taking our normal rectangular equation and splitting it up into two parametric ones. Now we're not going to figure out or go create parametric equations from rectangulars, but we are going to go from parametric into rectangular equations later on. So it's not really important for us to know right now where these equations came from. What's important is for us to know that we are introducing this third variable into our realm. So when we sketch them, though, when we sketch parametric equations, we have to substitute values of t. So we're going to be substituting these values of t into both equations. But because this could go in any direction, we need to draw an arrow representing what direction this curve goes. So we're going to substitute in values of t, and we're going to have negative starting at -2. So -2, -1, 0, 1, and 2. And then we're going to have our x value, and we're going to have our y value. So when we substitute -2 in for x, -2 in for t in the x equation, -2 squared is 4. 4 minus 4 is 0. And then substituting -2 in for t in the y, we have negative 2 over 2, which is negative 1. So our first point is going to be plotted at 0, comma, negative 1. Then we substitute in negative 1. Negative 1 squared minus 4 gives us negative 3. And then negative 1 over 2 gives us negative 1/2. So our second point is going to be at negative 3, comma, negative 1/2 right here. Then when we substitute in 0, for the x equation, we get negative 4, and for the y equation, we get 0. Okay, so then negative 4, comma, 0. So it looks like we're going to the left here, but now when we substitute in positive 1, 1 squared is 1 minus 4 is negative 3, and when we substitute 1 in, we get 1/2. So we have negative 3, comma, 1/2. And when we substitute in 2, we get 0, and when we substitute, we get 1. So 0, comma, 1. Now I forgot to go up to 3. When we substitute in 3, we get 5 for x, and we get 3/2 for y. Okay, so then 5, comma, 3/2. So 1, 2, 3, 4, 5, 3/2 right there. So which way do we connect these dots? This one might be a little bit easy to see that we are going to connect them like a sideways parabola, but it's not always that easy. So we have to start with that first point that we got, 0, comma, negative 1, and then we're going in this direction. So what we do is we draw arrows so we know what direction this goes in. Right, so graphing these is a little bit tricky, but we're used to graphing x and y points. So we're plugging in our t values into x and y, and then plotting those points, and then drawing that arrow. Now our graphing calculator can do this. And one of the things that we haven't looked at yet with our graphing calculator is the mode. So if we go to mode, we've always gone to radian and degree. But right below that, we see function, parametric, PAR. So watch, when I hit enter on that, that's highlighted. And now when I click y equals, look at, you see x1 of t and y1 of t. So if I were to type in those equations from the previous page, instead of x, look at when I press the variable button, I get t. So t squared minus 4. And then the other one was t divided by 2. Now when I graph that, let's look at the window. Oh, so look at our t min was 0, and it went up to that. So let's change this to what the problem said, negative 2 to 3, and we'll change our step to 1 because that's how much we went up by. So now look at, that's the same shape that we had. If we make our step smaller, let's say 0.25, we get the same shape. If we go to 0.01, we're going to get the same shape, but you see how it's taking longer to trace it out. So smaller values of our step means I'm going to be substituting in more and more points, but it should get us the same shape overall. Now that doesn't mean you want to just go and say, oh, let's just do a step of 5. Okay, when we do that, we get a totally different shape. Okay, so it's safe to say we always want to have a step of 1 unless otherwise noted. All right, now as I talked before, we said that we're going to go from parametric equations to the rectangular. So what you do is, for your parametric equation, it's called eliminating the parameter. We're going to eliminate t. So in one of the equations, we have to solve for t. We plug it in or substitute it into the second one, and then we simplify. Now, I hate dealing with square roots. So for this particular one, I'm going to work with the x equation and get t by itself. So x equals 2t minus 1. Add 1 to both sides. X plus 1 equals 2t. Divide both sides by 2. Oops. We divide both sides by 2. We get t equals x plus 1 over 2. Now we're going to substitute this entire thing into t. So then it's going to be y equals 2, but instead of t, we're going to write what t equals. X plus 1 over 2 squared plus 1. Well, x plus 1 squared in the numerator, that's going to be x squared plus 2x plus 1 over 4 plus 1. Now we can distribute this 2 to everything. Y equals 2x squared plus 4x plus 2 plus 1, and this is all over 4. So I'm going to split this up into 2x squared over 4 plus 4x over 4 plus 2 over 4 plus 1. Simplify our fractions. Y equals 1 half x squared plus x plus 1 half plus, I'm going to change that 1 to 2 over 2. And now we can finally rewrite this as y equals 1 half x squared plus x plus 3 over 2. And that would be our rectangular form of that parametric equation. So we're going to be using our algebra again. All right, now example 3, we're going to be eliminating the parameter and then using our graphing calculator to graph the parametric equation. And then we're going to find, use a calculator to find values of x and y for 5 t values. And we can choose whatever t values we want. We do want to be mindful of domain restrictions, like if we have the square root of t, okay, we can't substitute in negative numbers for that t value, or for those t values. So I usually like to try to do some negative and positive ones, but if we can't, then we'll adjust accordingly. So first thing I want to do is eliminate the parameter. And again, it doesn't matter which variable you solve for, you just want to get t by itself. I always like to work with the top equation, or try to get, this one is equally as difficult. Like I don't have a t squared or a square root or a fraction. So they're both probably equal difficulty to work with. So x minus 1 equals 4t. Divide both sides by 4. T equals x minus 1 over 4. So then we're going to substitute that in for t. So y equals 2 minus 3 times x minus 1 over 4. Distribute the 3. And then negative 3, 2 minus 3x plus 3 over 4. Y equals 2 can be written as 8 over 4. So y equals negative 3x plus 11 over 4 would be our eliminated parameter equation, and now we're in rectangular form. Now on the calculator, we're going to graph this, and for t, for x, and y, so negative 2, negative 1, 0, 1, 2. So our first equation, x was 1 plus 4t. Oops. 1 plus 4t. And then our second equation was 2 minus 3t. And we can graph this, but you see it goes on forever and ever. We can press trace and type in, -2, and you see the x value is -7 and the y value is 8. So -7 and +8. And then we can type in -1, and we get -3, 5. Another way of doing this is looking at the table by pressing second graph. Okay, so we have our t values and we have our x and y's. So when when t is 0, we get 1 and 2. When t is 1, it's 5 and -1, and then 9 and -4. So we're going to plot those points, -7, 8. All right, this one's going to go off the graph. 1, 2, 3, 4, 5, 6, 7, and then 8. 1, 2, 3, 4, 5, 6, 7, 8. Then we have -3, +5. 1, 2, 3. 1, 2, 3, 4, 5. Then +1, 2. 5, -1. And then 9, -4 is also going to be off our screen over here. So the curve is going this way because when we started with smaller t values, our points were over here, and as we got larger values of t, our points were going in this direction. So it's aligned with a negative slope. Well, if we look at our equation here, isn't that aligned with a negative slope? So that's just, again, another way to rewrite these. All right, now letter B. With this one, we have x equals t plus 4 and y equals t squared. I really don't want to work with the t squared because in order to get t, we have to square root both sides, and that's going to give us a plus and minus answer. So we would have even more equations. So I don't want to deal with that if I can help it. So I'm going to get the other equation for x. Subtract 4 from both sides, x minus 4 equals t. So then y equals x minus 4 squared, because again, I'm taking what t is equal to and substituting it in. Whoops, this should be squared. So then y is equal to x minus 4 squared is x squared minus 8x plus 16. So we have our rectangular form. Okay, so now going back to our calculators, it's going to be t plus 4, and this is just going to be t squared. Now watch, when we draw that, that looks like a parabola. The reason why it's cut off there is our window still only has from -2 to +3 because of that first problem. So let's change that now. -10, +10. You see, oh, it's a parabola. And that's what we got in our rectangular form. Y equals x squared minus 8x plus 16 is a parabola. All right, so I'm going to go second graph to get our table. And again, we're going to copy these down. So for t, we have -2, -1, 0, 1, and 2. And we have x, and we have y. So we have 2, 4, 3, 1, 4, 0, 5, 1, and 6, 4. So we're going to start at 2, 4. 1, 2, 1, 2, 3, 4. Then 3, 1, 4, 0, 5, 1, and 6 comma 4. So our graph connects like this, and it was going in this direction as we plotted those ordered pair with our values of t. And I don't know if you noticed that when we graphed this, that it started from left to right. It may not always do that, but for this one it did, so that's why we have to draw the arrows. All right, now on the next page we have some with domain restrictions. We have x equals ln of t and y equals t squared. Well, remember, we can't take the log of 0 or a negative number, so when I make my table, I'm not going to have -2, -1, 0. I'm going to start at 1. But first, let's eliminate the parameter, and it's probably equally annoying in both situations here to get t by itself, but I'm going to use the top one because this is x equals log base e of t. Well, we can switch that to exponent form. When we switch this to exponent form using properties of logs, we get e to the x power equals t. Well, now we have t by itself. So we can substitute this in for the y equation. So this is going to give us y equals e to the x squared. Well, we know e to the x squared, properties of exponents, says if I have an exponent raised to an exponent, we multiply that. So it's y equals e to the 2x. So now let's get into our calculators. And we're going to do the natural log of t in one of them. And the other one, oh, we already have t squared. Now when I hit graph, this is what we get. Right, so our graph is going to be pretty messy or off the grid, but let's look at the table. And we see when we substitute in anything 0 or smaller, we get an error in the x one. So that means we have to start at 1, and we're going to go up to 5. So t 1, 2, 3, 4, 5, x, y. So it was, when t was 1, it was 0 and 1. When t was 2, it was 0.7 and 4. 3 was 1.1 and 9. 4 was 1.4 and 16. And 5 was 1.6 and 25. And you may say, well, how the heck do we graph that? You know, we got x equals 0, then 0.7, then 1.1. If we make each of these grid marks maybe like 0.5, that could give us a good estimation. So 0.5. And then the y values maybe go up by 3s. That will give us some room. So when our first t value of 1, it was 0, 1. Let's use a better color. Then when t was 2, we had 0.7, 4, so more than 0.5, 4. Then we had 1.1, 9 right here, because 0.5, then 1, a little bit more than that would be right there. Then 1.4, 16. Okay, so we have 9, 12, 15. One more than that would be 16, and our x value is 1.4. And then our last one, 1.6, 25. So just a little bit over, but now it's going to be way up here. So that looks like an exponential equation, and y equals e to the 2x is exponential. So then the direction, our function went this way. All right, our last one. X equals the square root of t squared plus 2, and then y equals t over 4. Now, when I look at this, it would be pretty difficult to try to get t by itself in the first equation, the x one. We have to square both sides, and then minus 2. It just would be kind of messy. So let's instead look at the y one and multiply both sides by 4. And when we do that, we get t is equal to 4y. 4y. And now we can substitute that into this x1. So then we have x is equal to the square root of 4y squared plus 2. So x is equal to the square root of 16y squared plus 2. And because there's that plus sign in the middle of that square root, we can't simplify it. So that's as far as we would go. Okay, so then our table, t, x, y, y equals, let's get rid of that and type in the square root of t squared plus 2 over, or sorry, next for the y, it's going to be t over 4. And then we graph that. So second graph. Now we can do negative values for this one. And we're going to round to the 10th as needed. So when when t is negative 2, negative 1, 0, 1, 2, when t was negative 2, x was 2.4 and y was 1/2. So 2.4, 1/2. When t was 1, x was 1.7 and y was negative 1/2, negative 1/4. When t was 0, x was 1.4 and y was 0. When t is 1, 1.7 and positive 1/4. And when t was 2, 2.4 and y was 1/2. So now let's plot these points. 2.4 comma negative 1/2. So 1, 2.4 comma negative 1/2 would be right there. Then we had 1.7 comma negative 1/4, so about there. Then 1.4 comma 0 is almost at 1/2 comma 0. Then we had 1.7 comma 1/4, and then 2.4 comma positive 1/2. So it went in this direction, and we started down here, and as we drew it, the points went in this direction. So again, you're going to be using your algebra skills in order to get your t isolated and then substituting it back in. But it's very important that you remember or look and see which point came first, like with your t value, because we might have instances where instead we're going this way, depending on what the parameters are. All right, so thanks for watching. Make sure to like and subscribe.